Welcome back to everybody. So today I will discuss about relative motion. That means relative velocity concept here. So in the relative velocity, first one, the general relative velocity concept. So the relative velocity applications. So there are 6 applications are there. In generally that is upstream and downstream. So upstream means opposite to flow. Upstream nothing but opposite to flow for current river. So downstream means in same direction of flow. In direction of flow. So in that means cycle is moving in the direction of wind, that is downstream. Your cycle riding opposite to the direction of wind, that is upstream will come. Similarly, you are swimming in the direction of river flow, it is downstream. Opposite to the river flow, it is upstream. So next one, river boat problems. River in the river, how you are rowing the boat to reach opposite end. So if you want to reach a shortest path and you want to reach shortest time, or you want to reach exactly one point, it decided point. So in these 3 ways, how you have to row the boat or how you have to swim to reach that points. So that is will discuss. In rain umbrella, means in rain umbrella position. In what direction you need to keep umbrella? That means you are walking or you are standing. Depends on the rain direction. Relative velocity direction you have to place umbrella. So in wind aeroplane also same. And here velocity of approach is help to understand the concept of shortest distance between two particles when they are moving in different directions. So these all 6 cases are related to 6 cases. I mean 6 models of problems. In each case there is a different model of problem is there. I will discuss maximum all problems within 2-3 videos. So in this video I will try to explain upstream, downstream as well as river board problems. So now see, coming into upstream, swimming in a direction of flow. So then that is the velocity of the man plus velocity of the river will add. Downstream means, so this is upstream means here minus will come. In the downstream means here it will be plus will come. Downstream means, yeah, downstream means plus. So here same direction of flow. So it is wrong. And upstream means in the opposite direction of flow. Opposite direction of flow, upstream. Downstream in the same direction of flow. So now next general equation for relative velocity. So for example, VAB means the A is observing the particle B or person B, then VAB can be written as VA bar minus VB bar. So this is the approach of finding the relative velocity. So generally in relative velocity concept, we have a circular path. So here this is V1 because uniform circular motion, and here it is V2 are same, that is called root 2V. If theta is 180, that will be V1 minus V2. If theta is means theta is 2 pi means same point, so that will be 0. So like that means angle is given means we'll follow this method, that is already know vector addition. Uniform motion means V1 and V2 are same. At 180 degrees, after 180 degrees, both are in opposite direction. There will be it will be minus V1 minus V2. In the same, after reaching to the same point, displacement is 0, average velocity also 0. So in other case, in general relative velocity, in other case, we see here. So there are two particles are there, two persons are there, at A and at B. So their velocity is, A velocity is 10 meters second inverse and B velocity is 9 meters second inverse. So the velocity of A is more than B, then there is a possibility to meet A to meet B at this point. So when the VA is greater than VB. So VA is greater than VB. If VA is less than VB, never possible to meet both A and B. So in some model of problems, A is policeman, B is thief. In some model of problem, A is the person, the hero catching the bus. The heroine is there in the bus, so you want to catch the bus. So he is moving. And some cases, here bus or person is other rating they will give. So in that case, you have to find out V into T is equal to 1 minute. I will run. So V into T is equal to, so in that case of acceleration is given. So some D is the distance between those 2 points initially, then half AT square. So this is another formula. Means this is starting from rest and accelerating with acceleration A. D is the initial separation between those 2 points. So here there is 100 meters is the separation is given and velocities are given. So then 10t is equal to 100 plus 90. That means 100 is equal to, this is the method. Here I have given D. Distance between them is equal to, or after what the distance they will meet, or after what time they will meet, means D is equal to V relative into T. So then D is here. D is the initial separation is equal to V relative means 10 minus 9, because V1 is more, that's why 10 minus 9 into T I can. The same thing will come here. Then T is equal to 100 seconds. So this is generally how to find out the relative velocity. So now another question here. A man swimming downstream. That means velocities are added. So consider here the river velocity is V, small v, and man velocity, swimmer velocity is capital V. So he is swimming in downstream. Overcome a float at a point M. So at point M is overcoming the float. Means there is a float moving in the river with velocity, same velocity of river. After traveling the distance, and he return back and reaching that float. The float coming here now, d by 2, and by the same time in upstream, the person also traveled the distance d by 2. Means the time taken by the float to reach here is equal to the time taken by the person to travel to d distance and reverse d by 2 distance. You understand the time taken by the float to reach from this A to B is equal to time taken by the person D in downstream and time taken by the person upstream. So now this is d by V plus V plus d by 2 into V minus V. D by 2 means V minus V is velocity in upstream, V plus V is velocity in downstream. Here V is equal to velocity of river and capital V is equal to velocity of person considered. So now this is the time, the total time of wood. So that equal to d by 2 into V. The wood is traveling with the velocity of river only. River is taking it. So now by solving this, you will get this is the answer. So you can understand this. So next model of question on this general relative velocity, one more. You can see here, very important. Velocity of a motor boat with respect to still water, means velocity of the boat is given with respect to still water is 7 meters second. And velocity of water is 3 meters second. So when boat is start moving upstream, that means opposite direction. The boat is moving upstream. A float was dropped from it. So there is a one float. The float means one wood dropped from it. The boat travels 4.2 kilometers upstream. 4.2 kilometers upstream it traveled. In this time, how much time taken to travel in upstream is opposite to river velocity. In the same time, the float is traveled to the point A here. The float is traveled along with river to the point A. Means the float, how much time taken to reach the point A in with the help of river velocity, means VR into T is equal to VR into T is equal to that in the same time you travel 4.2 kilometers in upstream. Therefore, distance is equal to velocity V relative into time. Upstream V relative means velocity of the boat minus velocity of the river into time. So now if you try this, here it will be VBR minus VR equal to 4 will come. So T is equal to 10.50 seconds. So now the distance traveled by the float in this time is equal to VR into velocity of the river into this time. So that equal 3150 meters. So float is traveled this meters. The boat is traveled the same time 4.2 kilometers. Now he is returning. We observe that float is dropped and now he returned in the downstream. So now he will take less time out. Means now the float is moving A to C point or A to B point. By the time, from the time taken from A to B is equal to time taken by the boat to reach this one. That means the boat reaches the time. The boat reaches to this point, means 10 into T. How much time it will take? 10 into time is equal to VR into B. So that means to reach this point B, similar like AB concept, meters and 3500 meters. In this time VR into T is equal to V relative into T. This is the distance traveled by boat 10T. This you can take 10T is equal to initial distance in the upstream. Initial distance is equal to 4200 plus 3500. So V relative is equal, means D is equal to 10 into T is equal to V relative into T plus initial distance D. This formula. So here I have given Vt plus d plus Vt only. Here we are into t. So that is substituting now you will get total 35 minutes. Total time is upstream and downstream 35 minutes. So this is 2100 seconds, so then 35 minutes. So this is the applying the upstream and downstream and the general relative velocity concept for boat and thief and policeman or hero and bus. So this model of problems. Now coming into river boat applications. So in river boat, so here 3 points you have to remember. The 3 points are: one is the velocity of the swimmer with respect to still water, with respect to ground, and with respect to river. So in still water, the velocity still water means when you will say the velocity of the swimmer with the still water means the water is not having any velocity. It is calm river. Now he is swimming with his own effect to one point to another point. That is said to be velocity of the swimmer with respect to still water. So velocity of the swimmer with the ground also you can say same thing. So now in another case, he is having the life jacket. He don't know how to swim. He is wearing the life jacket and he is moving from one point to another point with the help of river speed. So that is denoted by VR. VR means speed of river. So means that part like float. Above cases, float how it is moving. Like here, swimmer also wearing the life jacket and moving to one point to another point. That is denotes by VR, velocity of the river. And now velocity of the means now the swimmer swimming in the flowing river or current river. Then the velocity of the swimmer with respect to ground. This is with respect to ground is equal to velocity of the man with respect to river and the velocity of the river with respect to ground. So this is because relative velocity of the man or swimmer with respect to river is equal to Vm bar minus Vr bar. So vector notation. So Vm bar minus Vr bar. Then Vm with respect to ground, Vr with respect to ground. So Vm, the velocity of the man with respect to ground is equal to Vmr means with respect to river plus velocity of the river with respect to ground. So this is formula. This formula you have to remember while solving based on the given velocity. Now coming into here in the first diagram. So A and B are opposite banks of river and AB represents the width of the river. So here D is width of the river. Now we started with initially angle theta with velocity V, Vmr this is. So I'm taking this is capital V and small u. So Vmr is equal to, in my explanations everywhere, Vmr is equal to, I'm simplifying, I'm taking as V for my convenience and Vr is equal to u. So this I will represent. Means when I'm giving V means it is the velocity of person with respect to or swimmer with respect to river or in still water. And Vr is velocity of river. So D is width now. We started V by making angle theta with river velocity. The angle theta is the theta between the theta is angle between the direction of the person swimming and river velocity. So now actually he directed to reach C. Because of river velocity, he drifted. He moved to C dash point. Directly can't move to C. So in fourth case, I will explain. You want to move directly C means what you have to maintain, how you have to maintain. But here, because of river velocity, there will be a drift C to C dash. And now, what is the time taken to reach blank? Here, time taken is equal to distance by the V sin theta. This is equation 1. And C drift is equal to here, in the place of drift, X I will go. Here, drift is equal to, I will go with Fx in my explanations. So now X is equal to, that is C dash here. X equal to U means river velocity plus V cos theta into T. Velocity into time. So this is equation 2. So now I want to reach the other blank B point in the shortest time. My aim is to move shortest time. So the time taken to reach the other blank should be minimum. To get the minimum time minimum from the equation 1, sin theta is maximum. Sin theta will be maximum. So that is equal theta is 90 degrees. That means you need to start vertically to the river velocity. That means perpendicularly you need to start. Perpendicular to the river velocity you need to start. So then you will reach opposite bank. But you will not reach directly to the blank, right up. Means end. There will be a shift, right? He started like this because of river velocity. So you will shift like this. So that will be drift. Drift will be there. But that will be shortest time. When he started like this, he will take shortest time. To take the minimum time to reach other bank, we must row perpendicular to bank. And now I want to reach the shortest path. That means exactly shortest path here it is exactly B. B point is shortest path. If you are going other than B from A, it will be hypotenuse will come. Anyhow, it will be more. So to reach the point B directly, I have to start from A to B. Means I have to go to B point, opposite end. That is shortest path. That means if I am moving any direction, I started one direction and I want to reach B, the drift should be 0. Here drift x is equal to 0. So what is u plus x is equal to u plus v cos theta is equal to 0. That means cos theta is equal to minus u by v. So here cos theta minus represents the theta value is more than 90 degrees. Therefore, to achieve the shortest path, the direction should be the direction of boat or direction of the swimming person. Direction is more than 90. 90 plus some alpha or 5, 90 plus 5. So that means here theta I have taken, theta has to sub. Means in this direction you have to start. More than 90 has to start to reach shortest path. So in this case, sin theta is equal to VR by means river velocity u by v. U by v. Cos theta is equal to minus u by v. Sin theta is equal to u by v. So these two degrees angle is it is clear. To achieve this to reach opposite end. Here minus. So sin theta value cannot be greater than 1. We know the value cannot be greater than 1. That means u by v cannot be greater than 1. So u cannot be greater than v. That means river velocity should not be more than the swimmer velocity. In this case, will not reach. So at that time, we will take cos theta is equal to, if such case is given, cos theta is equal to, we have to go, means direction of point means v by u will come, minus v by u. So it will be minus v by u will come, cos theta. Then this will be cos theta is equal to 5 plus sin inverse of v by v. So this is. So direction you have to start 5 plus sin inverse of v by u is the direction. You have to start to reach shortest path other bank. So to reach other bank, the velocity should be means ratio sin angle will be u by v. So u should not greater than v, then only we can reach. If u river velocity is more than swimmer velocity, the river take him to somewhere. Okay, it is not possible to cross the river. So that is okay clear. So in this case, you have to take instead of u by v, v by u you have to take cos theta minus v by u or sin theta equal to v by u you have to take. One problem is there, but not possible to discuss now. I will discuss later. So now I want to direct direct to point AB. I want to go to direct to point AB. In this case, the condition is to achieve this. My speed, the velocity of the swimmer V should lie along the line. Should lie along line. The line in which point I want to A to B in that line. So now in this case, so the vertical perpendicular direction, in perpendicular direction, the relative velocity should be 0. V relative is equal to 0. That means the velocity means here from the diagram, alpha is the angle between the direction of AB to the rowing direction, and theta is direction of line AB to the river. So now the perpendicular to this line, V sin alpha, perpendicular to this line, V sin alpha is equal to VR sin theta. So this is one condition. And my velocity means V cos alpha and plus VR means U cos theta along line AB. So now into T is equal to AB. So this is condition to direct. So in direct to directly I want to join one above means point on the other bank. Then the V should be lie along the means my velocity, the component of velocity. I want to swim. My velocity is always along this line. So in this case, my velocity means here my velocity V cos alpha is along this line, and river velocity cos component along the line. The remaining these two will be 0. The relative velocity V sin alpha minus VR sin theta is equal to 0. Therefore, V sin alpha VR sin theta is 0. Is equal to, they have to equal, and the components of my velocity which are there along the line, they have to fall on line. Then only I can reach. So now next some questions we will see in this. So first question number 1, see. Velocity of boat in still water 13 meters second was. Question is asking what is the difference between time taken by him to cross the river in shortest path. Shortest path means we need to start like this, shortest path. So here theta. So this is 13 and this is 5. Here 5. So hypotenuse is 13 and opposite is 5. Then this will be 12 will come. Therefore, time taken to shortest path is d by 12. So that equal to 156 by 12. That equals 13 seconds. So now, and shortest time. Shortest time means you'll start directly like this, perpendicular to the river body. You'll start like this. Shortest time. So now here is velocity is equal to 13 meters second force. So no need to divide the components. And d is 156 meters is given d. So not given means okay, we can go. Otherwise here given. So 156 by 13. So that equal to 12 seconds. So now difference is equal to 13 minus 12. So 1 second. I hope you understand. Now second question. The person swimming with 10 meters second was an angle 120 with the river flow. So that is like this he started. So this is the river flow. He started with the river flow like this. So this is 120 angle. So I can take this is as 30. Reaches to the point directly opposite on the river. So you want to reach to point A to point B. The speed of flow is x meter second inverse. The value of x near integer is asked. So here, so this is VR. And he started with speed 10. Therefore, sin theta is equal to VR by means u by V I know. So u is equal to VR here. So that equal to sin 30, 1 by 2. 1 by 2 is equal to u by V. V by u means 10. 1 to 5. Therefore, u is equal to 5 meters second. So very easy. So next problem. So a man who can swim at a speed v relative to the water cross the river with d flowing with speed u. The river is flowing here. River is flowing with speed u. You want to swim with v. I don't know in how he is starting. So to the point opposite him cross a river a. So you can reach the point in time. So you want to reach this point v point. You have to start like this, right? This is the v, and here it is u. So if you complete the diagram, this is theta. So now here it will be root over v square minus u square will come velocity. Or vb means v cos theta I can also take. V cos theta or root over v square minus u square. So now reach the time is asking. The time is equal to d by d is the width of river is given. Width of the river is d. So d by the velocity in that case is equal to root over v square minus u square. So the minimum time in which he can cross the river is d by v. Correct or not? We'll check. Minimum time means you need to start. Minimum time means you need to start with velocity perpendicular v. So no need to any angle. So then time is equal to d by v only will come. So that option is correct. So now it is already conceptual. U greater than v, it is not possible to. Similarly, coming into here, so I'll explain this within short time. So the ratio of the distance carried away by the water current downstream in crossing a river by a person making same angle with the downstream and upstream are respectively 2:1. What are the distances? So distances means shift to x is x1 is to x2 is equal to 2:1. Means drift. So that the ratio of speed of person to the water current cannot be less than 1 by 3 means so v by u should not be less than 1 by 3. This is I am going to show. So the ratio of distance carried away by the water current downstream and upstream. So let consider here. So the person is crossing the river in downstream. Downstream means he started like this with some angle. So this is the width of the river. So here time is equal to d by here v sin alpha and x is equal to x1 is equal to so v cos alpha plus u into t. X equal into t means d by sin alpha v sin alpha. So similarly the person is starting now. The person is starting upstream. This is the river velocity flow u. So here also river velocity u. So upstream with same angle here alpha. So here also time taken is equal to d by sin alpha. There is no doubt at all. Time taken is same to reach the point opposite point. But now x2 is equal to u minus v cos alpha into d by v sin alpha. The ratio of x1 x2 is given. The ratio of x1 x2 is equal to 2:1 is given. So therefore u plus v cos alpha by u minus v cos alpha is equal to 2:1. If you take now u plus v cos alpha is equal to 2u plus 2v cos alpha. So now u send that side. So here 1 is minus 2u. So that equal to 3v cos alpha is equal to u. Then is asking v by u into cos alpha is equal to 1 by 3. So if you take cos alpha is equal to u by 3v, or cos alpha is less than or equal to 1, positive cos alpha value is less than or equal to 1. So now if you take u will be u by v less than or equal to, here u by v greater than or equal to 1 by 3 will come. It not be less than 1 by 3. That is only is asking to find out. So here cos alpha is less than 90. Alpha values are less than 90 values. So that will be less than or equal to 1 value, cos alpha value. So cos alpha is equal to, from this you can go u by 3v. U by 3v. So from that v by u is greater than or equal to 1 by 3 is coming. So it is not less than 1 by 3. So this is fine. So thank you all. Thank you. Next I will come with the remaining topics.